Hello everyone, welcome to my channel. Dmitry Bonch is here. I'm going to make a series of videos in which I'm going to derive Einstein's field equations. But in order to understand all that, we first need to know the basics of calculus, and especially tensor calculus. So today is the first video. In this video I will explain what contravariant vectors and its components are. So suppose we have a space like this. It's a two-dimensional space, and in this space there is a particle that moves in this direction, and it has a velocity v with respect to two coordinate system x with x1 and x2 axis. This is our vector v, and it has two components x1 and component cx1 and component cx2. The total velocity is equal to cx1 plus cx2. It's simple. So now the component cx1 is equal to partial derivative of x1 value with respect to partial derivative with respect to time, partial derivative of time. Okay, so this is our component, x1 component. And now suppose we have a different coordinate system which is at an angle to this coordinate system. Let's call it y, with y1 axis and y2 axis. Now the components of this vector now will be in the y coordinate system will be different. Here is our cy1 component, cy1, and there is no space, but here is cy2 component. cy1 component will be equal to y2, partial derivative of y2 with respect to time. And in order to show how these two components relate to each other, we need to use the chain rule. So it will be equal to c partial derivative of y. Sorry, this should be y1 with respect to time. Oh, sorry. Partial derivative of x1, then multiplied by partial derivative of x1 with respect to time. But this part we have it here. So this actually this is the component x1. So we can rewrite this equation like cx1 is equal to cy1 is equal to cx1 multiplied by partial derivative of y1 to partial derivative to x1. So this is called a contravariant component of the vector v. Why it's called contravariant? Because if you increase x1, suppose it goes up, then y1 goes down.